Hi everyone. We're starting a new week and a new concept. This week we are going to be starting our discussion of functions. So that's this first video. What is a function? The basics. I want to talk to you about functions in its most basic form. So no fancy notation, no fancy terminology yet, just really basic and easy to understand. So I'm going to give you this definition. A function is a relationship or a correspondence between two collections of things. One of these is the collection of inputs, and the other, the collection of outputs. So that is the very first moment. We're not quite done with the definition of a function, but that is the first moment. And I'm going to use this opportunity to draw for the first time a really goofy picture that we're going to draw over and over again in this class. And that is, I draw a little machine. You'll notice eventually I start drawing sort of a scaled down version of it. Right? And this machine has a name, right? It can be called Acme. Maybe some of you will get the reference. And an input goes in. And then the machine does something. The machine has some process that it executes. We'll talk about that more. And then an output comes out. The process by which the machine generates an output for its input could be very complex. It could be very simple. It depends on the function. But that is the base idea of a function. You'll remember I said this is not the end of the definition of a function. So I'm going to add the rest of it in red. No input can correspond to more than one output. Okay, so this picture that I drew here with the little goofy machine, that's one picture that we draw a lot. Another picture that you'll see us draw a lot is this one. Two blobs, each of them with dots. So for the sake of argument, let's make one of the blobs have 4 dots and the other blob have 3 dots. And then we'll draw arrows. Or maybe for now we'll just keep them lines and we'll put arrows on them later. So what I drew here is a correspondence, right? So for example, this dot in the left blob corresponds to this dot in the right blob. This dot in the left blob corresponds to that blob in the right blob. And whenever you're looking at a correspondence, you could ask the question, well, is this correspondence a function? And the answer might be no, because a correspondence or a relationship could be something that doesn't quite cut the muster for a function, in which case it's just called a plain relation. So let's ask that question, is this a function? Well, if I ask you that question, the first question is, well, okay, but which ones are the inputs and which ones are the outputs? So let's say that the left blob represents the inputs and the right blob represents the outputs. Well, let's see. Do we have a correspondence between inputs and outputs? Yes, we do. If you give me something that's in the inputs blob, I can tell you which dot in the outputs blob it goes to. So this input goes to this output, this one goes to this one. So yes, I can certainly look and see what output each input corresponds to. So check. The other restriction is that no input can correspond to more than one output. Do any inputs correspond to more than one output? Well, no. This input, this top right-hand dot in the left-hand blob, that corresponds to this output here and no other ones. This input in the bottom right-hand corner corresponds to this one, okay? So it doesn't seem to be the case that any input corresponds to more than one output. Now, some of you might look at this and say, wait a minute, but isn't this weird? We have an output that two inputs link to. So that is not a problem. Two different inputs, I'm going to put this as a little asterisks here. Two different inputs can correspond to the same output. Okay? Later on, pretty significantly later on, we'll talk about something called a one-to-one function. And when we talk about that, then we're going to really think about, okay, what does that mean? And we're going to impose some more significant restrictions. All right. This is actually going to be a fairly short lesson, so I'm nearly done at this point. The only really other thing that I want to talk to you about is that for our purposes, functions will operate on real number inputs and produce real number outputs. So over here, when I'm talking about a function as a correspondence between two collections of things, that's very, very broad. And in fact, in general, a function really can correspond to, a function really can be a correspondence between any two things. But for our purposes, since we're really just starting this deep dive into the study of functions, we are going to keep functions down to things that take real number inputs and produce real number outputs. But just before we leave that arena, just to say we did, for fun, so I'm going to write this in a different color, that's pink purple. Just for fun, what do you think? Is this a function? Okay, so each student at CCSF maps or corresponds to the class in the math department. They're taking this semester. So when you see this, what we want to be thinking about, and really any time that you're thinking about functions, what you should be asking is, what are the inputs and what are the outputs? So the inputs are students at CCSF. And the outputs are the class in the math department that they're taking this semester. And so your question is, can an input, so can a student at CCSF correspond to more than one class in the math department that they're taking? And the answer is why, yes, they can. For example, all of you. All of you are signed up for 2 math classes this semester, at least. You're signed up for Math 90 and you're signed up for Math 90S. So it is not the case that if you pick any student at City College that they are only going to correspond to a single math class. There may very well be students who are taking more than one math class. So that's an example of a correspondence that is not a function. Okay, let's think about an example that maybe is an example of a function. So again, this is kind of just for fun. Is this a function? Okay. Each person who works at City College corresponds to their employee ID. So again, if you're asked that question, is this a function? The first thing we're going to ask is, what's the input, what's the output? So the input is each person who works at City College. And the output is their employee ID. Now, I suppose we could say, well, I mean, we don't know. But ideally, an employee ID is such that no 2 people have the same one. So that if I want to look something up about someone, unequivocally, I don't want to wonder if I'm looking at this person or that person, I should be able to put in their employee ID. So, at least by design, no person at City College should correspond to more than one employee ID. So, yes. And then just to add a little bit of reality in there, we hope, right? So, I mean, there may be glitches, but at least the way that the system is designed, no person should correspond to more than one ID. That would be ambiguous and very hard. So this is the beginning of kind of what is a function. Notice that I did not say a function is an equation. I didn't talk about solving a function. I didn't talk about any of those things because a function is not any of those things. All a function is a relationship, a correspondence between inputs and outputs. And I hope that even now we are setting that tone, that when we're talking about functions, the first and most important thing is, what does it take as its inputs and what does it put out as its outputs? And then the second most important question is, how does it make that transition? What does it do to the inputs to create the outputs? And that's what we'll talk about in our next lesson. Bye.